Find the percent composition by mass of each element in water. And water is H2O. So in water, you have the elements hydrogen and you have the elements oxygen. Now, what does it mean when it's talking about percent composition by mass? All right, what does this mean? Well, the first thing you're going to do before I tell you is you're going to have to know how to find the molar mass. You're going to have to find the molar mass for H2O. You're going to need to know how to do that. Now, basically, just to summarize it, I'll probably make a video on moles later, but basically, one mole of something, it's sort of like another unit. All right, so when you say that I have 1 dozen cookies, for example, right, I'm saying that I have 12 cookies, right? Let's say if I have 1 mole of something, well, that just means I have around 6.02 times 10 to the 23rd of that thing, right? So for example, if I have 1 mole of cookies, that just means I have 6.02 times 10 to the 23rd cookies. Why is this number so big, you might ask? Well, think about it. Moles are going to be your units for when you're dealing with things like atoms and molecules. And of course, in our universe, we have a lot of atoms and molecules, right? So it makes sense to, create a unit that, can kind of make calculations easier, right? I don't want to deal with such big numbers, such big amount of atoms, right? So I just use the mole unit and kind of just like simplifies everything. Okay. Now, the thing is that if you want to find a molar mass of something, all you have to do is you have to take the atomic mass of kind of each of the elements together, you add them together, and you get the molar mass. So for example, in H2O, right, what's the atomic mass of hydrogen? It's about 1.008. All right, so 1.008 for hydrogen. And because there's 2 hydrogens, we're going to multiply this by 2. Now, in H2O, we also have 1 oxygen atom. What's the atomic mass of oxygen? That's just going to be around 16. And because there's only 1 oxygen, you can think of this as multiplying this by 1. All right. So what does this come out to? Well, this comes out to around 18.016. And what you're going to do is you're just going to place a grams unit at the end. All right. It turns out that 1 mole. So in this case, it turns out that 6.02 times 10 to the 23rd H2O molecules. So if I have this many H2O molecules, it turns out that coincidentally, it weighs 18.016 grams. All right. I don't know who the hell found this out. How the hell they found this out. This is like a really cool coincidence, right? If you add up the atomic mass of all of the elements inside your compound, and reminder that atomic mass is measured in AMUs, right? It's a completely different unit. So, it turns out if you add all of these together and you put this grams symbol at the end, it turns out that that's actually something known as the molar mass for that compound, for that, thing, right? It turns out that, 1 mole of that is going to weigh, well, this much, all right? So we established that H2O, 1 mole of H2O weighs 18.016 grams. Now, percent composition just tells us, well, out of this 18.016 grams, how much of it is actually oxygen? How much of it is actually oxygen? Or how much of it is actually hydrogen? So if I want to find the percent composition by mass of, let's say, hydrogen in H2O, well, what's the sort of molar mass for hydrogen? Well, we said that was 1.008, right? And we said that there was 2 hydrogens. So 2 times 1.008 is going to give us around 2.016. So what you're going to do is you're just going to take this 2.016 grams and you're going to divide this by 18.016 grams. And that's going to get you around, so 2.016 divided by 18.016. That's going to be around 0.1119. All right. Now what you're going to do is you're just going to multiply this number by 100. So if I multiply this number by 100, right, I'm going to turn this into a percentage. Okay, so I'm going to multiply this by 100, and I'm going to get 11.19%. And all this is telling us is that hydrogen makes up 11.19% of the total mass in H2O. All right, this is all that this is telling us, right? Whenever you're doing percent composition by mass, I probably should have told you this earlier. My bad, guys. But the formula for percent composition by mass is you're going to take the part, right? So in this case, our part was the hydrogen, right? We're trying to find out how much the percent composition of hydrogen in this case, right? So you're going to take the part, right? How much it weighs, divided by the whole thing, how much that weighs, and you're going to multiply that by 100, right? So out of the whole sort of molar mass of water, well, what percent of that is, hydrogen, right? How much does kind of hydrogen contribute to the weight of this H2O? Now, of course, you can do the same process with oxygen, right? So if I have oxygen, right, I have one oxygen molecule, one oxygen atom. So that's around 16 grams, right? So 1 mole of oxygen is around 16 grams, right? And what you're going to do is you're just going to divide the 16 by this 18, right? This total thing. Remember that this is a part over whole, right? And then what you're going to do is you're just going to multiply this by 100. So 16 divided by 18.016, that's going to be about, times 100, that's going to be about 88.8%. Notice how when you actually add these two values together, you get 100%. And that makes sense because, right, in 1 mole of, so if I have 1 mole of H2O, right, that's basically going to be it's going to have the same mass as if you just took 1 mole. If you took 1 mole of H2 and you add that to the weight of 1 mole of oxygen, right? Because like 1 mole of H2O means that you have 6.02 times 10 to the 23rd H2O molecules, right? So you're going to have 6.02 times 10 to the 23rd hydrogens, and then 6.02 times 10 to the 23rd of this oxygen right over here, right? So it's like, this is kind of the equivalent weight of 1 mole of H2 and 1 mole of oxygen, which is why it makes sense that when you add these two values together, you get 100% of this total weight, right? Also, hold on. I didn't round to the correct sig digs. I'm sorry, guys. All right, this is 2 sig digs here, so should be, around 89%, but should be around 89%, but you get the idea, right? So you just divide part of the mass, right, by the whole thing, multiply that by 100, and you get your answer. And just a quick note, let's say, I don't know, if this was like, let's say H3O somehow, right, H3O plus, let's just say, right, what you're going to do is you're going to multiply the amount of hydrogens by 3, right? You're going to multiply the amount of hydrogens by 3. If, let's say, you had 4 oxygens, for example, what you would do is you would multiply the oxygen's molar mass by 4, right? And that would get you the correct answer, right? So just make sure that you're paying attention to this number right over here that's below this oxygen, right? Make sure you're multiplying the molar mass by that number.